Hi guys, today I am going to discuss cycles which are related to thermodynamic and power plant operations. First one, that's very important, Carnot cycle. Carnot cycle actually is a ideal cycle. Is the most efficient power cycle. Is the most efficient power cycle. The Carnot cycle of two isothermal processes and two adiabatic processes. Both these are processes are reversible, and therefore it is the most efficient cycle as it involves no losses. Theoretical heat engine that operates on the cycle is the Carnot engines. Let's we start the assumptions of the cycles. There are four assumptions. First one is the working material should be a perfect gas. And second one is the motion of the piston in the cylinder is frictionless. The Carnot cycle derivation was presented in a written format. You can see in the thermal efficiency, work done over heat supplied. Work done in form of heat, first one Q1 is the heat absorbed by heat engine from the heat source, and Q2 is heat rejected by the heat engine to heat sink. This is the heat source and this is the heat sink, Q1 and Q2. W is the work done. So work done, heat absorbed by heat engine from the heat source minus heat rejected by the heat engine to heat sink. In this cycle, there are four processes. For example, first one is process 1 to 2. 1 to 2. In TS diagram, process 1 to 2, reversible isothermal expansion, and 2 to 3, reversible adiabatic expansion, and 3 to 4, 2 to 3, 3 to 4, reversible isothermal compression, and 4 to 1, reversible adiabatic compression. What is the meant by Carnot cycle? Actually, it is applicable for perfect gas whose efficiency is considered to be maximum. What is use of the Carnot cycle? Carnot engine is a hypothetical heat engine designed based on the Carnot cycle where heat delivered to a system is used to obtain usable mechanical work. So in TS diagram, there are four processes and two processes are isothermal and two are adiabatically. But in this ideal cycle, entropy is constant. But in practical, there is no constant of entropy. There is no constant of entropy due to the losses in the pipe, in the engine, in other source. Actually, this is a perfect gas cycle based. So now we move to another cycle, basic cycle. Actually, there are four normally basic cycles. First one is Carnot, second one is Rankine, third one is Brayton, and fourth one is combined. In power plant system and in power plant operations, these four cycles are very important with respect to operations and with respect to understanding of the system. Whether that is the combined cycle, whether that is the coal-based or hydraulic-based, and or gas based. You can say thermal power plant. In second lecture, we will discuss about the Rankine cycle. Thank you.